Welcome to the Explainer. Today, we're going to talk about a really powerful feature in C++ that can make your code so much cleaner, more intuitive, frankly, just more natural to write. We're talking about operator overloading, and specifically how this one little keyword, friend, solves a super common and kind of tricky problem.
You know, when you get right down to it, good programming is all about making the code feel natural. We want to write stuff that's easy for other people and our future selves to read and understand. The code should really reflect the problem we're solving, not just the weird rules of the machine.
So take a look at this. On the left, you've got your standard member function call, a.add_b. Yeah, it gets the job done, but it reads like code. It feels clunky. But on the right, that's what we want to write, a plus b. It's clean, it's simple, it's exactly how you think about addition in your head. And that's the magic of operator overloading.
Okay, so how do we actually get that natural-looking syntax? Well, the most direct way to do it in C++ is to define the operator as a member method right inside the class itself. So you declare an operator plus function, pretty much like any other method in your class, and when the compiler sees an object of your class on the left-hand side of a plus sign, it's smart enough to know, aha, I need to call this function. Seems simple enough, right? But there's a catch. A sneaky little problem hiding in plain sight.
And this is where things get interesting. That member function approach, it works great, right up until the moment it doesn't. It creates this subtle but really frustrating issue, a lack of symmetry. Let's see exactly what that means. All right, check this out. Let's imagine our custom object can be added to a double. This line of code, myObject plus 2.0, it compiles perfectly. The compiler sees myObject on the left, translates it into a member function call, myObject.operator plus 2.0, and everything's happy. So far, so good.
But what happens if we just flip them around? 2.0 plus myObject. And bam, compiler error. So why does that happen? Well, the compiler looks at the double on the left, and it tries to find a member function inside the built-in double type that knows how to add our myObject. And of course, it can't find one, so the build just breaks.
So what's the deal here? The problem is that the member function approach makes the left-hand side special. It has to be an object of our class for the call to work. This totally breaks the natural symmetric nature of operations like addition, where we all just expect a plus b to be the exact same thing as b plus a.
So we've hit a wall. How do we fix this? How do we get that beautiful symmetry back? Well, C++ has this really elegant solution, a special tool for exactly this kind of problem, and it's called a friend function. Okay, so what is a friend function? The key thing to get is that it's not a member of the class. It kind of lives outside of it. And because it's an outsider, it doesn't play favorites. It doesn't have a special this pointer for the left-hand object. It treats both arguments, left and right, symmetrically. This lets the compiler do its magic on either side of the operator, which completely solves our problem.
All right, theory is great, but let's see this in action and make it really concrete. We're going to use a super classic example, something you've probably run into before, building a class for complex numbers.
Now, this is a really cool pro-level C++ pattern. Instead of jumping straight to the plus operator, the best practice is to first implement the compound assignment operator, plus equals, as a member function, because it directly modifies the object. Then you implement the binary plus operator as a non-member friend. And here's the really clever part. You implement plus by using the plus equals you just wrote. This keeps your code super clean, efficient, and you're not repeating yourself. So in our complex class, we declare our main operator plus as a friend. We can even add other friend overloads, like one that lets us do double plus complex symmetrically. And this last one, this stream insertion operator, operator shift, this one is super important. It has to be a non-member. Why? Because think about what's on the left side when you write std_cout shift myObject. It's cout. It's an OStream object, not our complex object. Declaring it a friend gives it access to the private data it needs to print everything out.
Okay, that might feel like a lot to keep track of, but don't worry. The crucial thing is just knowing when to use which tool. And it actually boils down to a really simple set of rules.
And here it is. This is your cheat sheet. Seriously. For any assignment operators, like plus equals, that actually modify the object, they belong to the class, so make them member functions. But for symmetric binary operators like plus, star, or equals, and for stream operators like XX, you need that flexibility of a non-member. Make them friend functions. It's really that simple.
And just a few final pro tips to help you write really solid code. First, don't get crazy with Friend. It's a powerful tool, but it does kind of poke a hole in your class's privacy, so only use it when you really need it. Second, always pass your objects by const reference to avoid making slow, unnecessary copies. And finally, get in the habit of marking your single argument constructors as explicit. This stops the compiler from making some really surprising type conversions you didn't ask for.
And this really brings us to the big picture here. We've seen how friend functions and operator overloading can lead to code that is just beautiful. It's elegant, it's intuitive. But, and this is a big but, when it's overused or used in weird, non-obvious ways, it can make code incredibly confusing. Like any powerful tool, its value is all in how you use it. So the real question is, what will you build with it?